Hello, guys. Thanks for joining us today again. Today, we decided to return to the basics of Java and we will talk about the exceptions. Uh, so exceptions is a very important topic that everyone should know. Everyone should be able to write his own custom exceptions or handle some exceptions that occur in the application. And yeah, as always, I remind you that you can ask all your questions in the chats on the YouTube or on the VR community. We will try to cover them all. And I'm passing the word to the Givi Kotsashvili. Good luck.
Thanks. Hello, can you hear my voice, Daniela? Just to test it.
Yes, you can.
Okay, so today I'm going to talk about a very important topic, which is exceptions in Java, and a very interesting one. And as we already mentioned, this is a topic that you might need in your daily career as a programmer, and you will face a lot, and this is a must to know. I will demonstrate what the workflow of our presentation will go like. I usually didn't want to have only theoretical part because it would be very boring, so I decided to have like custom examples for each of the topics discussed here, and I think it will be more interesting. In the presentation, we'll cover several topics which are very important, like for example, what is an exception in general, exceptions hierarchy, like types of exceptions, how to work with exceptions, custom exceptions, and etc., etc. So not to get too complicated, let's just start with the first topic, which is the exception itself, right? We have to discuss what is exception exactly. So exception is an event that disrupts the normal workflow of our application, and it is an object that is thrown at runtime, and it causes our program to terminate abnormally. Yes, at first I know that this might sound very strange, but in order to understand this better, I decided to bring up a simple scenario to this, and we will also get back to this description. Why did I write this stuff here? Okay, let's go to the IDE, and let's imagine something like this. Let's imagine an example that our boss, imagine an example that we are working in a company as an employee, as a programmer, like a junior programmer, and our boss decided to give us a task to create an application of a calculator which prints the result of division of two numbers. And he not only gave one task, he gave us two tasks. The first one is to print the result of division of calculator, and also the second task is that after the calculation is done, he wants us to print a very important information in the console also. So these are the two requirements. And to understand this, to realize this problem, let's just get to it and just create a simple calculator class. We'll call it calculator. And here I will have one method, which will be public void print which will take two parameters, int a and int b, and it will simply print the result of this division. So just to recap, we are creating a calculator class. Well, usually you might ask if the calculator has different functionalities, like to add two numbers, to subtract, to multiply, to divide, but let's just be focused on the division result, okay? I have created a method which takes two parameters and it simply prints the result of division of these two numbers. Now let's go to the main class now, and let's just instantiate this calculator class. And let's call the method, and let's input some values. It doesn't matter. Let's start with 10 or 2, for example. And the second requirement from our boss was to print the very important code. Let's imagine that the number really doesn't matter. This is just an example, just to quickly recap, not to get confused. So our boss gave us a task to print the division of result of two integers. And after the result is done, he also wants us to print this very important code also 1020, just for example. And if we run this application now, let's just wait for a second. Let's see what will be the result. And as we can see, the result is 5, correct? And printing very important code was also printed, which is very essential, and our boss is happy that we did the test correctly. And even if we try with different numbers, for example, 50 and 5, and if we run this, let's see what will be the result. Just a second. So yeah, the output is correct. Result is 10. Printing very important code is also printed 1020, and yeah, our boss is happy. Everything goes well, and our boss decided to make our application in prod, and users are already able to use it. But after some while, let's imagine a situation like this. One of the users decided to play with this calculator, and he accidentally input the divisor as to be 0. And just a quick recap, guys, if you don't know this in mathematics, this is just simple mathematics that you cannot divide a number by 0. It's simply illegal. It's not possible. And even I will prove this, even if you, sorry about that. Even if I open my calculator now, let's just test it. If I test 50 by 0, it terminated my program, right? And it also gave me a message, cannot divide by 0. Interesting, because this is simply not possible. But here's a question, guys. What will happen in the case if I run my code now? What will happen with my application now? Let's just run it and let's test it. Just a second. Oh, okay. We received an exception called arithmetic exception with a detailed message called /by0. And notice the fact, guys, not only that our calculation was incorrect, the very important code was also not printed. And our boss is very angry because we did not even manage to do one of the tasks. Both of them failed. And and now if I show you the definition, as I said, exception is an event that disturbs the normal workflow of our application, and it causes our program to terminate abnormally. And as we saw here, our program terminated abnormally, and it did not even print the code 1020. So yeah, our boss is now angry, and he decided to either kick us or either give us a chance to fix this problem. So actually, yeah, we have to fix this problem, but there are several ways to do this, right? The most simplest one to fix this problem might be to introduce, for example, if-else statement like this. Just give me a second. Introduce local variables. And write something like this. I will actually copy the message which was in the calculator just for fun. I want it to be the exact same thing. Cannot divide by 0. Okay, I will just copy this. Second one. And yeah, okay. If I run my code now, let's test it. What will happen? Just a second. So as we can see, everything is okay now. I got the error message that cannot divide by 0, and notice the fact that my program did not terminate abnormally. The very important code was also printed here, and our boss is happy because we did not terminate our program, and the result was correct, right? Like if you try with different numbers now, like for example 50 divided by 5, it will calculate the result correctly, which is fine totally. However, there is a better way to handle this situation, and it is something called like try-catch block. At first, you might wonder what is this, but I will quickly explain this. We can write something like this, and it's so the try-catch block, I will talk about this in more detail in the next slides, but just for now, remember that try-catch block is considered to be the recommended approach to handle exceptions. And in try-catch block, what are you doing is just you're examining a block of code like this, and you are catching particular exception if some kind of errors happening there. In this case, if a is divided by 0, if divisor is 0, we will catch arithmetic exception. And if I run the code now, let's see what will happen. Just a second. So yeah, everything is correct, but some of you might wonder that when I wrote if else and try catch, the result was both the same, right? So someone might ask, what's the difference between why not just write if else? So actually, I will talk about this in more detail on the last slide. For now, just remember that try-catch is the recommended approach, and I will explain this in more detail. And also, yeah, also one thing I will say that usually when you are logging errors, it's a better thing to write a system error rather than system out print. This was just an example of demonstrating the situation with error. Without print, sorry. And if I run this code now, let's see what will be the difference. So actually I have to write 5 here, sorry about that. Not 5, 0, sorry. Let me do this again, just a second. Okay, I got the same result, but in red. Actually, system error is something that we can use when we are working with error logs, because it's very helpful for a developer to analyze error, because its color is red and like it's easier to understand, right? So anyway, yeah, you can use that if you like. So let's go to the next topic, which is the hierarchy of exceptions hierarchy. So basically what we have here is that in Java, we have predefined exceptions, right? Because as you noticed, I have used arithmetic exception, and we have not like created a class for it. We just used it because these are predefined. And the hierarchy looks like something like this. We have division of exceptions, which are divided into checked exceptions, unchecked exceptions, and errors. And at top we have throwable and we have object. Like at first, some of you might wonder what the hell is this, but we'll get into detail of every case. Don't worry. I just want to quickly recap what's happening here, and we will like constantly showing. I will be constantly showing this slide because it will be very helpful. At first, we have throwable derived from object. Just a quick recap. If you create any object in Java, it derives from the object class. So its superclass is always object, because object class contains methods which are like hash code, equals, toString, and etc. that are needed to work with objects, right? And the throwable is the main class of all exceptions. I will talk about throwable in the next slide. Just remember, it's the main class of all exceptions, and we have like division of exceptions like checked exceptions, unchecked exceptions, errors, and as you can see, arithmetic exception, which we just used, was a runtime exception, which derives from exception, which is throwable, etc., etc. So, like, not to get too confused, let's describe throwable, and then we will discuss everything, and it will be like moving to these slides one another. Okay. So let's talk about throwable. So throwable is the main class of all exceptions. Exceptions are objects in Java, right? When you throw an exception, you throw an object, and you just cannot throw any object as an exception, because it should derive from throwable, right? If an object does not derive from throwable, it means that it is not considered to be an exception. For example, if you create a person class, if you create animal class, if it does not extend throwable or any other sub exceptions like checked exceptions, runtime exceptions, or errors, it's not considered to be an exception, and you can just not throw it, right? And since throwable is a exception, is an object, it is a class, right? A class may have methods or may not have methods. In this case, throwable has a lot of methods which are very useful. I will talk about the most useful ones, most common ones, which are get, message, and print, track, trace. Actually, there are lots of them, and I will talk about like suppress and get suppressed, etc. in the next slides. Just let's be focused on these two. Okay, now I will demonstrate the get message and print stack trace example. Just a second. Okay, what we can do here, instead of a system error, instead of just this message, we can do something like this, e.get message. So I told you guys that arithmetic exception is an exception, and it derives from throwable. If we go to the hierarchy right now, just a second, I told you that we will be constantly seeing this hierarchy. We have arithmetic exception, which derives from runtime exception. It derives from exception. It derives from throwable. And if I go inside this class now, let's go arithmetic exception extends runtime exception. Okay. Runtime exception extends exception. Okay. And exception extends throwable. Okay. And as you see, throwable has lots of things here, lots of methods, lots of things here. So what we can do here is that in the main class, since arithmetic exception is an object and it derives from throwable, we can use all of the methods of throwable, right? So we are using get message. The get message will return a string of detailed message of why the exception occurred. And if we run this code now, let's analyze what will happen. What happened here is that we got an error message, which is /by0. Some of you may ask, this is not a very descriptive message. Maybe I agree, okay, but this is how the arithmetic exception describes it. It's not written by us, it's written by the Java developers who created this exception, right? So this is detailed message of the arithmetic exception itself. And usually this get message is not only used for logging, it's also used for testing, which I will show you when I will do the testing part also. But now just remember that it's a very useful method, and we can also have another method called print I can pronounce it, print stack trace. So actually what this method does is that, let's run it and analyze it. It's a very useful one, and you will see it constantly when you work with exceptions. And as you can see here, I got the detailed message of which exceptions occurred, the detailed message of the exception itself, and I also got the place where the exception occurred. It occurred in line 11. And I noticed the fact that I also received the very important code. Print stack trace is similar as we saw when we throw an exception. It just prints the detailed message of the exception, also the type of exception, and also where the exception occurred. And it's very useful in our daily lives. So yeah, okay, that was about it. Now let's go to the next slide, which is types of exceptions. And as you can see from the slide here, we have different types of exceptions, which is runtime exceptions, which is checked exceptions, unchecked exceptions, and errors. And we will talk about them, what is the difference between them. In Java, usually we have three types of exceptions, which are checked exceptions, also known as compile time exceptions, unchecked exceptions, also known as runtime exceptions, and errors. Errors differ from exceptions. Let's talk about each of them. A checked exception, as already said, is a compile time exception. A checked exception is considered to be exception in which is recoverable from, and it's more likely a user-side error rather than a system one. Unchecked exception is an exception which is also known as runtime exception, and it is considered to be unrecoverable from, meaning that it's usually more likely a system error rather than a customer one. And by word recoverable, I mean that the user is able to do something to recover from this exception. That's what the recoverable word means. And also errors. Yeah, errors actually differ from exceptions. Don't miss this. Errors are not exceptions. They are a separate topic. Errors are considered to be a very serious problem in our system, and they should not be handled. Errors should be fixed, and usually errors are something that are related to memory management, where we have like memory leaks or some kind of memory problems. Also, checked exceptions are considered to be handled. However, unchecked exceptions are considered to be fixed rather than handled. However, there might be some cases when you have to use try-catch block to analyze the unchecked exception. But usually when we work with checked exceptions, it tells us that there is a problem and we should fix it rather than handling it or printing some errors or some logs. So yeah, I want to briefly talk about how to work with exceptions before we go to the next example. Yeah, exceptions, we can work with exceptions with try-catch block. In try-catch block, as already mentioned, we examine our block of code, and in case of some kind of error happens or some kind of exception happens, we are catching that exception and like working on it, like printing logs or doing some specific stuff and so on and so on. Also, all blocks must be ordered from the most specific to the most general one, meaning like arithmetic exception should come first before exception. And at first, for some of you, this might be very strange. What the hell does this mean? But don't worry, I will show you in just a second. Like I will firstly talk about final block, and we will talk about this also. So I also want to talk about final block. So we can add a final statement to our try-catch block, meaning we can have like something like this: try, catch, finally. And the idea of final block is that it runs regardless of the result. It runs the statement regardless of the result. What will be if there will be an exception, it will still run. If there won't be any problem with the code, it will still run. However, a quick note here, there are some cases when the final block may not get executed, and this is when we might use system.exit, for example, in the try block. Or there's like also other possibility that you maybe shut down your computer during when you were working in the try block, but this sounds something crazy. But anyway, yeah, there are some possibilities of final block not to get executed, and one of the most best one is system.exit in the try block. So not to get very confused, let's just jump to our example to analyze this problem better. Just a second. Actually, what I have done here is I've already written the code because I don't want to write this code from scratch because it will take time and it will be uninteresting. I'll just copy it here and let's just analyze it, what's happening here. Okay, this at first sounds something very strange, right? But don't worry, we'll explain it in detail. So we also see here some array index out of bound exception, catch. Finally, what is it? Okay. Let's say something like this. In try block, we can not only call methods, we can write any block of Java code we want here, right? What I'm doing here, I have created an array of size 3, and I have assigned values like 0, 1, 2, the indexes with different values like 10, 12, and 13. And what I'm trying to do here is I'm trying to system out print the value of index 0, index 1, index 2, and etc. Nothing very complicated. And I'm also catching some exceptions here, which is array index out of bound exception, which we will analyze just in a second. We'll also catch an arithmetic exception, as you can see, which we discussed, and also exception. Okay, and we also have this final block here. Okay, and it's the same statement, like print very essential code 1012 and 1020. And so let's just run the code and let's see what will happen with this. Just a second. And just a second, let's wait. And as you can see, okay, everything is correct. Printing value of 0 is 10. Everything is correct, okay, guys? But notice the fact that we also printed very essential code. This is because the finally block was called. Finally block will be called despite if the exception occurred or not. It will run in any case. And here arises a question: why did I write so many catch statements here? And someone might ask, can we have several catch statements? Yes, and I will talk about this detail in further slides, don't worry. But for now, let's analyze some of the situations, okay? As you can see, my array size is 3, right? And array size 3 means that we have indexes 0, 1, 2, okay? But what will happen in the case if I assign a index 10, for example, which doesn't exist because the array size is only 3, right? And I'm assigning array at 10 to be equal to 30. And this is strange. What will happen? Let's test it. In this case, just a second, I see that array index out of bound exception occurs. And notice the fact that very essential code was also printed because it is in the final statement, despite if we try block through an exception or not, it will be printed in any case. And yeah, array index out of bound exception is something that when you assign an index which does not exist. And yeah, also I want to demonstrate the second example, which is 30 divided by 0. Okay, we already talked about this. When we divide a number by 0, we will get an exception, right? And let's test it. Because we are assigning index 2 to be an invalid value, which is arithmetic exception occurs, see? So the idea of several catch blocks is that you may get array index out of bound exception, you may get arithmetic exception, or you may get another exception, who knows? Like if I will do something like this, now look, if I will assign this array to be null, okay? This is something strange. We are assigning a value on a null instance. So if I run this now, let's see what will happen. Other exception occurs. Okay, this happened because we are assigning a value to a null. And this is basically a null pointer exception, and I will talk about it in more detail. You can just write here null pointer exception and it will work the same. And the thing is, which I also want to talk about, is that, yeah, in this slide, I mentioned that all blocks must be ordered from most specific to the most general one. So what does this mean? For instance, if I copy this code, the exception, and if I write here then I will get a compiler error, because the arithmetic array index bound exception and arithmetic exception both were caught already in the exception. So it's very important to write exceptions from most specific to the most general one. And someone might even ask, why did you write array index outbound exception first and not arithmetic exception? This is because array index outbound exception is more specific than the array arithmetic exception, because it extends the index outbound exception and it extends the runtime exception. And if we go in the arithmetic exception, we see that it extends runtime exception. So logically, this is more specific than one another. So yeah, this is an example of try catch finally. I won't delete it. Sorry. Okay. Let's go to the slides now. And I also want to talk about the few important notes about try catch finally, and this is that we cannot have an empty try block without a catch or finally related to it. We cannot have a try block we can have a try block and final block without a catch block. We cannot have a catch block and final block without a try block, and we can have only one try, one finally, and many catch blocks in a single try catch finally block. And let's not to get too complicated, let's analyze this situation. Okay, so what I mean by that, so we cannot have something like this, an empty try block, because it needs to have either a finally or a catch statement to it, because we also get a compiler error here that catch or finally is expected. We cannot have something like this, because it says that without a try, we have to have a try block nested with a catch or finally related to it. We can have something like this, which is quite interesting. Try and final without a catch block. And this is possible, actually, guys. And because you are examining code and you might just throw an exception and then handle it with finally or something like that, but it's possible. And also what I want to say is, this is also possible, as we already analyzed a try and catch. And yeah, one more thing. I mentioned that we can only have one try, one finally, but several catch blocks in a single try catch statement. What I mean, as you can see, I can have 3 catch blocks, even 10, even 12, and anyhow, how much I want. Anyway, but I cannot have like something like this finally, another finally here, because this is considered to be a separate try catch finally block. It's not possible. You can only have one finally block. And this is also not possible if you write try here. This is also not possible because this is another statement. This is also not possible. Just remember that. So yeah, other than that, that's good. Yeah, now let's talk about what are we going to talk about? Different scenarios. Okay, yeah, we also have to talk about custom exceptions in Java. As I mentioned, we have our predefined exceptions, right? I will go in the slide just a second. Yeah, these are the predefined exceptions in the Java, like arithmetic exception, null pointer exception, final unfound exception, stack overflow, and so on and so forth. These are all predefined. However, there are some cases when we want to create our own custom exception, right? And the idea of custom exception is that it provides us possibility to add additional information to our exceptions and to be more specific, like detailed message and etc. And this is very useful for developers to analyze the problem. Why did it occur? Where did it occur? Etc. Instead of like just throwing exception or null pointer exception, you can just be more specific by creating your custom exception. And for your creating exceptions, it's a bad practice to just extend the throwable, and it's a good practice to always be specific which exception you are deriving from. And what I mean by that, if you're creating checked or unchecked or error, you should be based on several facts. Let's just talk about this. For creating custom checked exceptions, we extend the exception class. If we are creating custom unchecked exception, we extend the runtime class. If we are creating custom errors, we extend the error class. But few notes here, guys. Usually, I personally have never used or ever seen a person creating a custom error, and usually it's not the developers don't make custom errors, but if some kind of possibilities that you have to do it, you can do it by extending the error class. But I personally have never seen it. And usually one also notice that modern frameworks rely on runtime exceptions more rather than checked exceptions. And like runtime exceptions are more commonly used than checked exceptions nowadays, just a note. And yeah, someone might ask, when we are creating a more custom exception, we have to choose between checked, unchecked, or error, right? So how do we distinguish between them? Well, think like this. If exception is recoverable from, and it's more likely customer-side error than the user one, customer-side error rather than the system one, then we should choose a checked exception. If exception is unrecoverable from, and it's more likely a system error rather than the customer one, which create a unchecked exception. And if there is some kind of serious problem in the system, like shortage of memory resources, problems with memory leaks, problems with resources, which causes memory arrangement, this is considered to be an error. And I will also talk about this, and I'll bring an example of error. But now let's jump to creating our custom exceptions in Java and how this is done. Let's go. At first, I will delete this line because we won't need it. And what I will do here is that I'm going to create a user service, and I will explain why. And imagine a situation like this. I imagine a situation when our boss asked us to create a website, and one of the customers decided to have such kind of functionality. Imagine I'm a customer, Daniela is a customer, for example, Walter is a customer, and me, Gui, I want to check, I want to have functionality to search other colleagues, customers' names by their name, if they exist or not, okay? Well, usually when you do something like this, you will have a database, right? But for storing the customer names and et cetera, et cetera. But for this example, I will create just a list for it to be more understandable and not too complicated for you guys. I will just create a list of, for example, customer names or colleague names. It doesn't really matter. And I will create a list of names, which will be Kiwi, which will be Danila, which will be Walter, for example. Walter. Walter. Okay. We have to import this. Okay, open good. And we have to create such kind of method which searches a user by his name, okay? I will do something like this, public string, which returns a string when it finds it based on if finds it or not. And the name will be get customer by name. And it will take an argument, a string, to search for the customer. And what it will do is that if, for example, customer names that contains name, if name is present in the database, but in our example, it's just a list, but in reality, you will have a database, you will search in the database. And if the name exists in the database data, for example, then just return the name. Or you can even write, I don't know, exists or something like that, but they will just return the name. And else if the customer name does not exist in the database, then we will do something like this, throw new user or employee not found exception. Okay, we are throwing an exception, but we haven't really created it. So let's go and create it. I will create employee not found exception. And notice one fact, guys. There is a problem here because, as I mentioned, not all of the objects can be thrown as an exception, right? Because as we see here, required type is throwable and provided this employee not found exception. The problem here is that we have just created a class, nothing more. It should extend either throwable, runtime exception, error. So this is, imagine you just created a class called person, animal, and it does not extend the exception. It's not considered to be exception. That's the reason why we can throw it here. And what we can do is, let's think for a second. Let's think if this exception is checked or unchecked or an error. So let's think like this. A user is searching an employee with a name which does not exist in the database. So is this a system problem or a user problem? Well, and is it recoverable from or not? Well, actually, if we think this, it is a user problem because user is searching something which does not exist in the database. So this is not a system error, this is a customer one. And to fix this, he should provide the correct name, and this is logically recoverable from, because user just can provide the correct name from the employee. Okay, so we extend the exception class, because if it's a checked exception, we extend the exception class. If it's unchecked, we extend the runtime exception. And we will also, and I will also create a constructor here, because I want to demonstrate to you how does the detailed message work, because it's very useful. Message, and we will call the super method of the exception. We're calling it super method, and it will print the detailed exception message. Okay, and what we are doing here is that we will also provide this detailed method message, which will be employee with a given name not found. Okay, employee with given name not found. And there is also one problem here. It's still showing red. And why is this? Because when you are working with checked exceptions, you should add a method signature on the method declares throws employee not found exception. So I want to talk about this in the next slide. Just remember that when you work with checked exceptions, your method has to declare throws keyword. Otherwise, you cannot work with it. Okay. And if we go to the main class now, and if I will use this user service, right? User service, new user service. And if I will system out print user service get customer by name, and I will on purpose specify a very dummy name, which doesn't exist in the database. Dummy name. This name does not exist in the database. In case the database, I mean that it does not exist in our list, right? And we also, as I mentioned, when we are throwing in a checked exception, we have to add a method signature, because the main method is also a method, right? This is also a method, and we also have to explicitly say that this method throws employee not found exception. And don't worry, I will talk about this in the next slide. Just let's stick to the custom and creating custom exceptions, okay? And now if I run my code, let's see what will happen. Just a second. As you can see, I got my own custom exception, which is employee not found exception. And I also got a detailed message, employee with given name not found. So this means that the user has incorrectly input the username, right? Other colleague's name. And this is very useful, because these types of exceptions help the developer to analyze why did this exception occur and how to fix it with the help of detailed message and the help of detailed information, okay? Let's analyze one more example, create one more example, and this will be something like this. Imagine your customer decided to have a new functionality, right? And this is like in the web page, you have teachers, for example, and the teacher usually has a students, right? And let's imagine a situation where a teacher has thousands, millions, like very large amount of students, right? And our database can only hold, like, for example, 100, 10,000 students, no more. But the teacher has lots of students. So I will write an example for here from now to like understand the problem better. I will create like a student list, which will be, let's give different names like George, Anna, and Mike. And let's create a method called public list of string, which will return the list of all of the students which are present for the teacher, sorry. Get all students, or get students, all get students. What this method does is that it returns student list. And the thing is that imagine a situation when the teacher is keep adding students, adding. And let's imagine that our database can only hold 3 students. Yes, this is a terrible example, but let's imagine that our database is very low memory and can only hold 3 students. And what happens if the teacher keeps adding the students? If, for example, new student was added, like, for example, Tina, or new student was added, like, for example, Shota, and so on. These are, by the way, Georgian names. So anyway, and in this case, if students are being added, our database can only hold 3 students, right? And in this case, we can throw an exception if student list size is greater than 3, and throw new teacher data to large exception. Actually, you can name this differently if you want, like student to data to large exception, or data to large exception, or something like that. And we are going to create this custom exception now. I'm going to create, can I copy this by the way? Yeah, I can. I'm going to create a class, and now let's think logically, is this a checked exception or unchecked exception, or etc., etc.? Well, logically, this exception is unrecoverable, because if, for example, the teacher wants to have 1,000 students, he can't, because our system does not allow it, because we have a low memory database. And this is more likely a system error rather than a user one, right? So the user cannot do anything to recover from this problem. We as the developers have to explicitly fix this problem by, for example, increasing the database size, or maybe printing some logs for the user that our database can only hold like 3 students, no more. So in this case, this is a runtime exception. Runtime exception is also known as exception, and we can also like create a constructor here so that we can have detailed message. Sorry, we'll have a message to have a detailed message. Okay, and now if I go back to the code, and and also note the fact, guys. I have to print the message. Employee data, like teacher data too large. Yeah, notice the fact, guys, this is unchecked exception, and it did not write the statement throws compared to checked exception, right? And yeah, as promised, I will discuss this in the next slide, but now let's go and test it. I will go in my main class here, and I will do something like this. I will do user service, like get students, and let's see what will happen in this case. And this throws is not required anymore. Yeah, we got our custom exception, which is teacher data to large exception, and teacher data to large is the detailed message here. This is the type of exception, this is the message, and it also printed where it happened. So usually, as I mentioned before, you should never handle errors, you should fix them. But for exceptions, there might be cases when you might, sorry, not exceptions, runtime exceptions, unchecked exceptions, there might be a case that you may handle it with some log statements like print, sorry, our database can only hold 3 students, or we are temporarily working for this functionality to improve. But usually unchecked exceptions, runtime exceptions, tell you that there is some kind of problem in the system and you should fix it. So this exception basically tells us to like increase the memory, or etc., etc. So anyway, yeah, this was an example of creating custom exceptions in Java. And yeah, we also have to talk about difference between throw and throws, because I promised this. Yeah, what's the difference between these two? To simply remember this is that when we are using a checked exception, we have to explicitly declare the statement throws for the compiler to understand that this is checked exception. And for unchecked exception, we don't have to do so, and it's not required to do so. And yeah, basically, if you look at the code, unchecked exceptions are more readable compared to checked exceptions because you are writing another statement there, throws. And usually, throw means that you are throwing an object as an exception. And throws statement tells us that our method will throw this or that type of exception for the compiler to understand. So that's the main difference between these two. Just remember that checked exceptions use the signature throws, and unchecked exception don't use it. Just it's not required. Oh yeah. Also, I want to talk about the exception testing in JUnit. Basically, this presentation is not based on testing, right? This is based on exceptions. So I will not be focused on testing. I just want to demonstrate how to test a basic example of exception because we created one, right? So usually if I go in my code now and if I, what is this? Sorry. If I go to the user service, as we can see here, let's analyze the get customer by name, okay? Here we have two conditions. If a username contains name, and else if it does not contain, then we have second condition. And usually when you are creating tasks, you have to explicitly test every functionality, right? You have to test what will happen if the username contains a name, if username exists in the database, or you also have to check what if the username does not exist. You have to check both. But since this is just an exception presentation, not testing, I will just be focused on the exception part. What we can do here is we can press Control Alt T, Control Shift T, and Control Shift T. Okay, and we can create a new test. We will call it user test. Okay, we will have a before method. Okay, and what I'm going to do here is I'm going to create an instance of my user service, and I'm going to instantiate it. Yeah, by the way, maybe someone might ask, this is not the best testing practice, etc., etc. This is not focused on the testing. We are just going to test how to test our custom checked exception logic, that it works or not. And what we can do here is that we can write a test. And we can give it a name, test get. So what was the name of the methods? Just a second. The name is get customer by name. We will call this get customer by name when a user does, or customer or employee, doesn't matter, where user does not exist. Throws user or employee not found exception. And also, yeah, why user? We should have here employee does not exist. Okay. I forgot the okay. Exist. I have trouble here. Anyway, okay, what we can do here, we have to test our logic works or not, okay? To test this, we are going to use assert throws, which will basically check that we're going to examine a block of code and we're going to test it, that it throws a specific exception. And let me just write this statement here and I will explain everything in detail. This will throw employee not found exception. What is this anyway? Employee not found exception dot class, and I'm going to have a lambda function here, which will basically write user service customer names, get customer by name, and we will on purpose specify dummy name because as I mentioned, this is a test for employee. Sorry, not for employee. This is test for the exception, and we're just going to text exception, not the part where user does exist. And we can also here specify something like a message here. If this is not the case, what will happen? Employee not found exception was expected. Was expected. Okay, if I run this code now, let's run what will happen. And let's analyze what I'm doing here. So the test passed. Okay, why did it pass? So we have used the assert throws, and we are checking that. So we are expecting an employee not found exception, and then we are analyzing, like running some block of code, in this case in Lambda function, which is user service got customer by name, and we're providing a dummy name here, which doesn't exist. And get you customer by name should return employee not found exception. And if it does not, then we'll get a message employee not found exception was expected because if I go here and throw, for example, instead of if I will throw instead of this, I will throw new pointer exception, for example. And if I go to my test once again, if I run this, the test will fail because I was expecting employee not found exception, and rather no pointer exception was provided. As you can see, employee not found exception was expected, and the test failed because of that. So I will return the same logic here, because we also have to mention one fact, and this is you can actually do something like this: employee not found exception. You can be more specific to test your assertions, right? And what you can do here is that assert equals and detailed message exception dot get message. And just a second, I will copy the exact name of the detailed message. I will copy this. And as you can see here, I mentioned that the exception that get message is a very useful method, because it returns the detailed message of an exception. And if I run this now, just a second, we are not only expecting employee not found exception, we are also expecting that the detailed message is correct for this exception. If I, for example, write here lol, and if I run this now, it will fail because they are not the same. Let's just check it. Yeah, it failed. As you can see, the name I expected was this, and it was different. And I also mentioned to you guys that the get message is not only used for like printing logs, it's also very useful for testing purposes. And as you have noticed, I have created I have a custom exception. And custom exception comes with all of these method get message, print struct trace, and add suppress, and so on and so forth. And this happens because our custom exception, for example, employee not found exception, extends the exception class, and exception extends the throwable class, and throwable has all of these methods, right? So that's the point, because if an object doesn't derive from throwable, it's not considered to be an exception, right? So okay, now we're going to talk about the next topic, which is inheritance rules of exceptions. This is quite interesting one. There are basically three rules of inheritance and exceptions. This is the first. If superclass declares an exception, then the child class may not declare an exception. The second one is if child class can only declare runtime exceptions, but not checked exceptions if the parent does not throw a checked exception. So if the parent does not have exception, then the child may only have runtime exception. That's the case. And there's also a case when a parent class throws a checked exception, then the child class can only throw unchecked exception, and also only the exceptions, only the checked exceptions, which are at lower level of the same. If exception is higher level, then it's not possible. And not to get too confused, I'm going to demonstrate this example just now. What I'm going to do here is,
I'm really sorry, but we're running out of time. Maybe we can skip this example to cover everything else.
Oh, okay. So yeah, this is just the basic inheritance rules. I'm just going to talk about also the best practices working with exceptions. So the best practices are several ones, but I just mentioned only three of them because this is the most common ones. And this is always try to catch particular subclasses instead of general exception, to never have empty catch block, because if you are swallowing exception in this case, and error swallowing is a bad practice, exception swallowing, because you're not doing anything with the exception, you should at least log some statements or write some kind of block of code to handle this exception. Always catch only those exceptions that can be handled, because if exception is not it can't be handled, there is no point of handling that exception. Like for example, Stack Overflow error, you should not handle it, you should either fix it. I also want to talk about try with resources, and try with resources was introduced in Java 7, which allows us to declare a resource which will be closed automatically after execution. Because if you don't close a resource, there might be a case when you might run out of memory error, or you might face memory leaks. And to either make our object eligible for try with resources, our object should implement either closable or auto-closable. And let's just demonstrate this example. Should I demonstrate the example, Daniela? Do we have time? Okay, I'll create an example then. So let's imagine something like this. I'll copy this code just to be faster. And let's imagine we will do something like this. We will create a scanner, and the scanner is basically a resource which scans our file and reads it. In this case, for example, I have also created a file here. If you can see, it's my name is Gaby. I'm 23 years old. I have big arms. This is just a file description, and I'm going to read it through my program. And to do so, I'm going to create a scanner. I'm going to instantiate it, and then I'm going to scan each line. And if in case the file does not exist, we're going to catch an exception, file not found exception. And in final block, we are going to check if scanner is not equal to no, then we're going to close resource. So basically we are closing resource, because you should always close resource, because there might be a case when the resource is still open and it might run out of memory leaks, may cause problems, and etc. etc. As you can see here, if I run this code now, I will do as quickly as possible. If I run this code now, file not found exception will occur, because text, it should be text, right? Text txt. The file was read and it was printed, right? So, and after that, the resource was closed. However, there is a better solution to solve this, and it is by using try with resources. It's something like this. I will write in a second, just a second, guys. And I will copy this code. And I will do something like this. Scanner. And scanner. And what I'm trying to do here is that, why I'm getting an error. What did I do wrong here? Scanner, new file. So anyway, I don't know why this problem is happening now, but this is the same thing as writing the code which I just demonstrated to you. And basically what you're doing is you're opening a braces and you're examining a block of code there, a block of resource there. And as you can see, we have only written a few statements compared to the other, and it has closed the resource automatically because the scanner class implements the closable. As I mentioned, for a resource to be eligible for try with resources, it should either implement closable or auto-closable. So auto-closable, just a quick recap, auto-closable is a better better thing to use, because auto-closable is the newer version, and it is more specific than the closable, because it works with exceptions rather than IO exceptions. So if you are thinking of creating your custom resource, you should you should implement the closable. And since I don't have a lot of time, I will just skip the part of creating our customer source, and I will just move on to the next examples. And we will go through. Next topic is null pointer exception, which is very important to cover. A null pointer exception is an exception which happens when we are referring a null instance. For example, if I create quickly a person class, and I will have one method called public string get person name, and if we will return PV, for example, it doesn't really matter. And if I go to the main method here, I'm going to write something like this. Sorry, person, no, person, and we're going to system out print person.get name. And if I run this code now, it will work. However, just let's check it. Yeah, it works. However, if I assign this object to be null, it won't work. It will throw a null pointer exception. And the null pointer exception is basically when you are referring to an instance which points to a null reference. And this is basically the same thing as writing a null here. So it won't work. And anyway, this is a runtime exception also to null. Yeah, this is a simple example of how null pointer exception can occur. I'm going to talk briefly about suppressed exception, and maybe we don't have lots of time, so I will quickly recap this. Suppressed exception is an exception which is thrown but somehow ignored, and a simple example of that might be when we throw an exception from the finally block, which might sound very strange. But there are some cases when exception may be thrown in a finary block, so this is a suppressed exception. And since we don't have lots of time, I will quickly explain what you should do this. The throwable class also has add suppressed and get suppressed method, and you can basically, instead of, you can add a suppressed exception to the current exception. So since we don't have time, I won't be able to demonstrate this, and I will quickly talk about why. So just check out these guys, okay? So suppressed exceptions with some examples. This is a must to know, and I will also talk about the try-catch block instead of if-else, why we should use it, because I mentioned this in the first beginning. This is that try block is considered to be the recommended approach because it's more readable compared to if else, and it's more maintainable. If you have a large code, it becomes very hard to work with if else, and try catch is a better approach because we are not predicting on prediction. So if else is based on prediction, and try catch is not based on prediction, because there might be some cases where you can't predict the exception to occur, and it might occur. So it's better way to use try-catch block. Also, in a try-catch block, we can use throwable methods because we are catching a particular exception, right? We can use print stack trace, get message, and suppress, and so on and so forth. So it's better use try-catch block. And I also want to very briefly talk about Stack Overflow error because we haven't really talked about errors too much. And I will very quickly create an example. Imagine something like this: public int static int calculate factorial. And what we're going to do here now is that we are going to int n, and we're going to return n times calculate factorial n minus 1. So yeah, quick recap. What is factorial? Factorial is a multiplication of, factorial is the sum of multiplication of all positive integers for a given integer. Basically what this means that factorial of 5, for example, if we calculate factorial of 5, this will be 5 times 4 times 3 times 2 times 1, which is 120. And someone might ask, what the hell is this? Anyway, this is something called recursion. Recursion is when you are calling the function itself for several times until a baseline. So when we first enter with 5, it will be like 5 times 5 minus 1, which is 4, and then we will go through 4 till 4 minus 1, which is 3, and we'll go to 3 minus 1, which is 2, and etc. And there is a problem here, guys. If I run this code now, I will get a problem. I will get an error here. And the error will be Stack Overflow, and I will explain why. And as you can see, errors really differ from exceptions, right? We have a huge problem here. Yeah, so why did this happen? This happened because when we have called the recursion, we have never have a base statement. This function will go like 5 times 4 times 3 times 2 times 1 times 0 times -1, and it will go to infinity. And this is a huge problem because it will never stop. And local variables, just a quick recap, local variables are stored in stack. And although when all of these variables are stored in stack, the stack is overloaded and we get the stack overflow problem. So in order to fix this, we will write something like this. If n is equals to 1, return 1, but you should be careful here. You should write n is less than equal to 1, because if you go with -5, it will go to -6, -7, -8, -9, and so on. It will never be 1, okay? So this is the best way to fix this. Now if I will run my code, the problem is fixed, and notice the fact that we have not 120, okay, and notice the fact that we have not handled this error, right? We could have written something like a stupid thing like something like this, and we could have caught the errors, stack overflow error, and we could have just system out print or print strike rate, but this is a terrible idea because you are destroying your program and then you're just catching this error and printing it. This is a terrible idea. Errors should be never caught and they should be fixed rather. And someone might even say that maybe the best thing to do here is just to increase the stack size instead of just writing this base statement, but that is also a bad idea because if you increase the stack size even with 10, 20, I don't know, maybe 100, the problem will still occur because this will go to infinity, and that's not the case. To handle it, the best way to handle this, you should not handle with try catch. You should rather fix an error. So yeah, this was example of Stack Overflow error, and sorry, can I exit the? Okay, and yeah, basically, I think that was all. Thanks for listening, guys. Sorry that the lecture was too long. I didn't expect that, and yeah. We also couldn't talk about the separate exceptions examples, but we talked about theory. So just look for it, okay, guys?
Okay, can you put the comment here?
Yeah, thanks a lot for the great presentation. I will just have my 30 seconds of commercial. As always, I remind you that we have a free Java online school that you can enroll for free today or tomorrow, but better today. Why wait for tomorrow? MJC.school, it covers everything from the create and main methods and up to modern frameworks. So basically everything that junior Java developer should know. And yeah, if we get a question in the chat right now, we will answer it, but I don't see any questions. Yeah, probably there are no questions, so we will share the codes if you would like to play around with it or see the presentation again. And thanks a lot, Gibi, for the presentation. Thanks, guys, for joining, and see you next week on the next Light Talk.
Okay, thanks. Bye, guys. Hope you liked it.